Hi everyone, welcome back to my channel. In this video, we're going to pick up where we left off earlier in training our breast cancer detection model. And so what I went on and did is over here in the numerical columns, as you might remember from last video, I asked you guys to go ahead and experiment with having the different columns that are shown here as part of this so that we can normalize all of this data. And so I went ahead and added all of those columns in. And now, after I trained the model, I was able to get a slightly higher accuracy of 96.5%. And then when we go ahead and look at the visualization, you can kind of see that there ends up being this kind of line over here, if you wanted to imagine it, that differentiates the two categories. So what we're going to do this time is we're going to experiment with different k values, which are the amount of nearest neighbors that the KNN looks at. And kind of in the next video, I'm going to explain more about the KNN model. And we're also going to look at the comparison between this uniform model versus a weighted KNN. Let's go ahead and dive straight in. Since we already have all of our data loaded from the last video, we can go ahead and start by defining our neighbors. And we're going to put it in a range of 1 to 21. Now we're going to go ahead and create an empty list that stores our accuracy scores. So if we remember from earlier, we look at the accuracy score. We also look at the precision scores. And then lastly, we were looking at the recall scores. All right, and now we're going to go through all of the different values of the neighbors using a for loop. And so all we're going to say is, like it shows here, for k in neighbors. And then now we're going to create a KNN instance that has the number of neighbors in it. So it's just going to be KNN is equal to k neighbors classifier, and our number of neighbors is just going to be equal to k. Next, we are going to now fit this new classifier that we created onto our training data. So we're just going to go KNN fit on X train and Y train. And then lastly, now we want to make a prediction on our testing data. So Y prediction is going to be equal to KNN.predict on X test. And now we want to get the accuracy scores and add them to our empty lists that we created over here. So what we're going to do now is we're going to say accuracy is equal to accuracy score of Y test versus Y prediction. And then we're going to say accuracy scores dot append accuracy. And so what this is going to do is that in the end, after our for loop is done looping through all of the numbers and neighbors, we're going to have a list of the various accuracy scores that each of the neighbors got. And that's going to allow us to kind of compare the different values. And through this, we can see like what's the correct amount of neighbors that we should have in our model that ends up giving us the right accuracy score. And so we went ahead and did the same thing for precision and recall. And I'm going to go ahead and run this block of code. Now that it's run, now we are going to go ahead and plot all of these accuracy scores so we can kind of get a better look at things. So we're just going to use plt.plot. We're going to plot the amount of neighbors that we had and then we're going to plot our accuracy scores, and our label is just going to be accuracy. And we're going to do the same sort of thing for our precision scores, with our label being precision. And then lastly, we're going to do the same thing for our recall scores, and our label is recall. All right. Now we are going to just do a general labeling of the graph, and it's going to be number of neighbors, which is going to be on the x-axis. And then our label for our y-axis is going to be accuracy. For our title, just because it might be a good idea if you're scrolling through your code at any point to know what you actually plotted, we're just going to say it's the comparison of the accuracy, precision, and recall for different numbers of neighbors. Okay? Then we're going to try to get a legend on the side. So we're going to say plt.legend, and then we're going to go ahead and obviously show our graph. And so once we do this, and it loads, you can kind of see here that we had a spike in accuracy when we had, let's see here. So we had really good accuracy when we had around 2.5 neighbors. So I'm going to guess this is at the 2 neighbor point. And then likewise, we had a spike in accuracy, precision, and recall at I think that would be around the 4 neighbors point. Then from there on, our accuracy went down. Our recall also went down until some more spikes, but our accuracy never really came back up to above 97%. So this kind of shows us that we should keep our neighbor at either a value of 2 or 4. If we go back up, we see that we set our value of k to 5. So if I want, what I can actually do is I can try changing the value of k to 4. When we run it, we automatically see our accuracy has gone up from 96.5% to now 97%, which is kind of what our graph predicted for us. If we do the same thing for 2, we'll just see the same accuracy over there. So I'll just leave this at 4. And that way we know that the value of 4 for the number of neighbors is gives us the highest accuracy. All right. So now the last thing we're going to do here is we're going to try experimenting with different weighted KNNs. So if we go ahead, and what we're going to first import is something called the select k-best class. And we use this from the scikit-learn library. And what it does is it basically creates a scoring function that assigns different features a score. And through that, we're able to select the most important feature out of all of them. So that's the first thing that we're going to import. So what we're going to do is that from sklearn.feature selection, we're going to import select k-best. All right. And then the next thing we're going to do is we're going to import something called fclassif. And this is, again, one of the scoring functions that we can use. And what it does is it basically computes a statistic between each of the features and the target variable that we're trying to do. And through this, like what the select k-best does, is we're able to see which feature is the most important in determining our output. So we're going to import fclassif. Okay, and so now we want to basically create a fixed value of k. So what we saw earlier is that when our k was 4 or 2, it gave us the highest value. So we're just going to set it to 4. Now we're going to create an instance of the KNN classifier where we use different weights on the features. So we can say KNN weighted is equal to k neighbors classifier with our number of neighbors is going to be k, and then like it says here, our weights is going to be the distance. And so now based off of what we're going to do next is based off of what the select k best and the f classif do, we're going to try to select the top features. So we're going to say selector is equal to select k best, and our score function here is going to be equal to f classif, and our number of neighbors is just going to be equal to k, which is 4, and then our x selected, we're going to fit our selector onto x and y. All right, if we scroll up, if you need a reminder of what x is, x contains all of the values of the different features, and y contains the diagnosis. And we used an encoder, and we changed the diagnosis to either the label encoder, and we changed the diagnosis to either 1 or 0. So if we go back to what we were doing, now we're going to try to get a mask of the different features that we selected. So we're going to say selected features mask equals selector dot get support. Now we're going to list the index of all of the different features which were selected. We're going to say selected feature indices is I for I, selected in enumerate, selected features mask if selected. And I'm going to go ahead and get rid of the sign. And now we want to print our selected features so we can see which features actually impact our accuracy the most. And then we're going to say for I in range length of selected feature indices, we're going to go ahead and print it out. So we're going to use data.columns, selected feature indices, selected feature indices, and then we're going to take I. All right, let me, it says there is an error over here. Okay. If I go ahead and run it, it should tell me the error. Oh, for I, it should be in range, out of there. All right. So once we run it, we can see that the features that it selected are the concavity mean, the fractal dimension, texture worst, and concavity worst. All right, so what this means is that these features have the highest impact on determining the different classifications of the cancer cell. So now we're going to go ahead and run our model again, the weighted model, and we're going to see what kind of accuracy we get. So once again, we're going to do xtrain, xtest, ytrain, and ytest is equal to train test split. And this time we're going to use the x selected, which are our features that we selected. And we're going to go ahead and use the test size as 0.2. and our random state will remain 42. Now, we want to fit our weighted classifier onto this new data that we have. So we're going to go ahead and use X train and Y train. And then our Y prediction weighted is going to be equal to the KNN weighted predicted on X test. And now we're going to take a look at the accuracies. So our accuracy is going to be equal to accuracy score of Y test and Y prediction weighted. And we're going to go ahead and print out our accuracy. It's accuracy. And we're going to do the same thing for precision and recall. Okay, print, precision, and recall. Now if we go ahead and run it, let's see here. Oh, I see the issue. So the semicolon should be inside of that, and then we should have a comma. There we go. All right, so now if we run it, we should get our new accuracies. So we can actually see that because we were able to figure out the number of neighbors that gives us the best accuracy using a weighted classifier actually gives us a lower accuracy. So what this kind of means is, the impact of the number of neighbors that you use is more important than the impact of, your selected features, essentially. So it's honestly worth trying both, using both this iteration method where we iterate through the number of neighbors, as well as the weighted KNN, because you never know when the weighted KNN could actually end up having a higher accuracy. So there you have it. You were able to tune your KNN by adjusting the number of neighbors and also experimenting with various weights that can improve your performance. I will put a link of this code down below in the description. And if you like this video, please subscribe, like, and comment for more machine learning tutorials. And in the next video, I'll go ahead and explain how the K-neighbors classifier works and how this entire model actually ran. Thank you. Bye.